Whoops, I've been talking this whole time. Hi guys, welcome to MetiSpaces. We'll begin in just another minute while a few more people flow in. But thanks for joining us for now. I'm gonna go ahead and put on some music. 𝘔𝘐𝘚 recently left the industry, so we'll play some 𝘔𝘐𝘚 today.
Is it brighter, brighter when I'm with you? Is it afterglow? Yes, I'm enough to light this fire, fire back in us. It's still the shadows are still open, though we're apart. I got this feeling, I wanna be where you are. I wanna be where you are. I wanna be where you are. I got this feeling, I'm where you are. I wanna be where you are. I wanna be where you are.
All right, guys. Welcome to MetiSpaces, brought by the 𝘝𝘐𝘚 Foundation. We are dedicated to the community education and collaboration within and beyond the 𝘝𝘚 ecosystem. And today we are inviting our newest eco node, Project zkEVM, along with Taiko, a decentralized layer 2 blockchain protocol that uses zero-knowledge Ethereum virtual machines. Today we have Pavel and Cecilia. How are y'all doing?
Hi, thank you for inviting me.
Hi, thank you for inviting me too, and pretty good.
Awesome, great. So we got a lot to discuss about. We have Project zkEVM, which is building a general purpose virtual machine, and we have Taiko, who has been and has their established zero-knowledge Ethereum virtual machine. I'm going to go ahead and start with Cecilia, since you're our guest today. Can you go ahead and tell us a little bit more about Taiko?
Okay, sure. So Taiko is a type 1 zkEVM, or we originally started and marketing ourselves as a type 1 zkEVM. And now we're working on decentralizing prover and proposer and the entire protocol of decentralizing zk proofs in layer 2. So yeah, so Taiko is basically like a zkEVM layer 2 with decentralizing proposer builder. Prover, yeah. So that's it.
Cool, awesome. Thanks, Cecilia. Pavel, go ahead and tell us a little bit about zkEVM.
Absolutely. So zkEVM is a project building a general purpose zkVM. So in this way, we aim to make provable computation using zero-knowledge proofs. And so in this way, you can run various different types of applications that you would in the real world on this zkVM. So it's very extensible and highly adaptable into different segments.
Awesome, cool, yeah. And then to get into the core of the show, this is all about EVMs and VMs. So we see, I mean, I was just like looking online and doing some research for the past few days, and I see a lot of like news about zkEVMs, but I don't see too much about like general purpose virtual machines. I kind of want you guys to banter a little bit. Could you tell me, Cecilia, what are the advantages of zkEVM, and how does it help kind of like the end user?
So I will say that zkEVM stems from the fact that if you use EVM to execute, and the trend of zk started from like scaling Ethereum, right? And Ethereum just happens to be using the EVM as its execution layer, and that's why it started off as a zkEVM effort to do zero-knowledge computation of the execution that happens on Ethereum, right? So that was the motivation. However, these days you've been seeing like zk and RISC-0 and all of the other general purpose zkVM that are happening nowadays. So I think it's a natural trend that once we started, we can go further, right? Like we advance the technology furthermore. So yeah, I wouldn't say they're comparable. I mean, they are comparable because zkEVM intuitively is more specialized, right? And zkVM itself is more general purpose. But I wouldn't say there's good and bad between those two. Yeah, so that was my take.
Yeah, I agree with that point. Essentially, one is built specifically for the zkEVM is built specifically for the Ethereum virtual machine running smart contracts. zkVM is more general purpose. We're using the MIPS instruction set, which is, I think it's like 35 years old. It's fairly old. And so what that means is that it's adopted to a large group of devices. And so a lot of them can be communicated in this way. And so I think that the comparisons between zkVM and zkEVM are very different, but still focused on the zk space. So hopefully that answers the question.
Yeah, for sure it does. And I kind of like want to take more of like a little step back too. So, you know, the MIPS instruction set, all these different reduction sets, and zero knowledge has kind of been around since I think 1985. But we're really seeing this like major ramp up in zero knowledge technology now. I just kind of wanted to pick your brains first before we go into the next question. What are like the use cases that you guys have seen in like the traditional Web 2 industry for zero knowledge proofs?
I would say the most intuitive one is like the usage of data, right? Like if we have to use some data to train machine learning models or identity, for example, insurance company who has to like use your data to verify that you certainly have some track record. That would be a traditional use case of zero knowledge proofs. Yeah, and also I think the idea of scaling computation doesn't happen till the adoption of blockchain. So like what you said back in like 1980s, when the professor was just starting to research about zero knowledge proofs, the use case that they're talking about are like privacy, right? Like you're able to prove that you have some data without revealing them. That was the original narrative. And nowadays you're using it to prove you honestly, like to prove that you carry out some computation with integrity. So the narrative started to diverge because of the emergence of blockchain. Yeah.
Yeah, and to add on to that point, privacy I think is the biggest proponent for zk, and then it's also that integrity of the data. We want to make sure that the program was executed in a full correct way, and so we can essentially develop applications and systems that allow you to not reveal any more information than you need to get access to certain systems. So the example I like to use is the ID card, where in order to get into a bar or anywhere, you have to provide your essentially full name, your address, your signature, I guess the area you live in, and so on and so forth. Whereas they're just looking for your age. And then you can use essentially that to reveal only a specific subset of information, not enough to basically attribute you as the individual. And this is, I guess, less applicable to the bar, but more applicable to when you're actually going and using the internet, because your data is exposed in every single situation. And so having that limited access, I think, is very important. So I think that's a very good use case that can be applied to many industries. So verified computation as well as the privacy.
Awesome. Yeah, and this is all like wrapping into the question that I have, and it's hard conceptual right now because we can't really decide where things are going, but we, like as Cecilia mentioned, we have seen a major ramp up in zero knowledge technology moving forward, incorporating it into these machines and into many different protocols in the industry. And in your guys' opinion, what sects of the industry do you think knowledge proofs will hold the most value?
I would say for now, apparently it's scaling, right? That the fact that you're able to prove that some computation happens and happens like elsewhere without you carrying out the computation, because so that you can save space, you can easily shift some like heavy work to some other places that has the resources if you don't have the resources locally, and that's what we always do as an engineer to like optimize um, systems, right? Because like resources are limited in this world. Most of the resources exist in the cloud, while people has like mobile devices, and a lot of places doesn't have very supreme computational power. But still, as we move on in this data intensive society, computational integrity and security become more and more important, and that's why we need proofs. Yeah, so that's scaling, and the shifting of computation itself, and of course privacy as well. As you know, like we're getting ripped off by the Web2 companies like Google and Facebook. We're still relying on their login system. We're still relying on them to record our history and all that stuff. And if we can privatize that in the future, with like fully on chain or not on chain, whatever, zero knowledge proof, I think that's a prompt future.
Yeah, and oh, sorry, go ahead, Pavel. You go ahead.
No worries, no worries. I just the point that I would want to add, to essentially emphasize that the scalability is, I think, the biggest use case currently popular. I think a lot of zk-based rollups, zk-based privacy solutions as well, like Aztec, and I think they're very hot in the blockchain space. I think in the future there might be more ways that we can essentially leverage it outside of scalability. That data privacy is still very important, and it's a very big problem, as Cecilia mentioned, and especially with the data providers. So I think that right now the rollups, the scalability side, and in the future there will be more focus on that, on the privacy aspect and general computation when that becomes further developed.
Yeah, for sure. I think like within the industry, like for however long anyone in the audience has been around, they've heard one of the number one things that you hear in the news is scalability. Every protocol is working towards being scalable. So yeah, I think you guys hit the dot, and everything else would follow right after. Make it like we can like grow this and then actually be sustainable for data privacy and everything that follows it. But yeah, so and then I also just kind of want to jump into the fact that, like, I mean, working for a cause, and we all know the current market conditions are kind of lacking. Everyone's starting to quiet down, which is interesting if you guys think the same. But but we're starting to see like Web2 merge more with Web3. So we have like Canton Network, AWS, other cloud computing providers. What do you guys think in the blockchain industry? Or sorry guys, I've been sick for the week, so I'm like still getting my brain together. But so what do you guys think in the blockchain industry? What would it look like in the upcoming few years when we finally break through this kind of like breaking through the scalability issue, kind of like perfecting that, and then being able to move forward?
I think it's definitely promising for the blockchain industry, because of the fact that more regulations are coming. For example, the ETFs that the U.S. Congress just approved. Like we just have like Ethereum ETFs on the market now, in addition to the Bitcoin ETFs. And yeah, the reason why I mentioned the TradFi aspect is because I still think that blockchain is a payment system. We got to bank the unbanked. By the end of the day, right? And I think that's when we really gain real world backgrounds are not stabilized by itself, right? Like for example, Africa or the South American continent and all those things, right? Like once we're able to deploy our technology there and get mass adoption, I think that's when the infrastructure that we build are actually meaningful, right? Like, because like, for example, Taiko is a layer 2, and we have a ton of layer 2s. But who uses this layer 2? Like, we just do like NFT on chain and do airdrop, and I don't think that's super meaningful, right? Like, I think in the future, if we can have like, if we can create value to people that are poor, to like to people that exist in the real world, I think that's when the next bull market will come. The next meaningful bull market will come.
Yeah, exactly. The applications that people will develop on the layer 2s themselves. So layer 2s are there for scalability, but then scalability of what? It's the programs, it's the actual applications. And I think that the zk aspect has, and especially the general purpose computation and the privacy components make it very lucrative for not just consumer apps, but also maybe governments, but also corporations, not just small, medium, big, everyone essentially. I think that there is with more essentially with more of these types of adoption happening, especially with the new regulation coming, with essentially more privacy preserving, again, we know that anytime anything is posted on chain, it's there forever, permanently, and so we can't really take it off, we can't scrub that, but there may be that intermediary where we can have ways that we can privatize that information and still be clients in these different types of regions. And then when WorldCoin comes and everything happens in that area, I do want to make sure that my privacy is maintained, and that's not everything is revealed and with all of that. So I'll leave it at that, and to say that the progress is looking good in the future, and definitely we need more verifiable computation as well as more privacy and security for our applications. And I think that's what will drive and is looking to drive future growth within this space.
Yeah, I think once we achieve like autonomous privacy, that everything would just, crypto adoption would really just take place and just push forward the way that, the internet bubble did. And like, that's also one thing is, so Pavel, you just mentioned like on the blockchain that everything will be recorded, you can't really hide from it. Do you think that's anything different from like the concept we have now in Web 2? Like growing up, I was always told, hey, if anything on the internet, it can be anything, but anything you do on the internet stays on the internet. Does that I don't think that concept really changes in blockchain, does it?
True that there might be aspects, but there's also you can limit the amounts of information that would get shared, and I think that ability to limit information or limit access to that information, we don't have that currently, right? Everything goes to Google, everything goes to Facebook, your birth date and whatever, and then that's associated with your identity, your profile, that gets sold to Cambridge Analytica and all that. With zk proofs, we're able to essentially provide attestation that I am who I say I am without revealing who I am. I mean, there might be a different phrasing, but I can verify that I'm over 21 without actually revealing my age. So I think just having those isolated segments where you're able to provide more information to maybe a government organization or less information to Google or Facebook, I think that there'll be a spectrum. And with these tools, we're given more opportunity to essentially develop these systems that will utilize them, because we don't want to give all the information away right off the bat, and then you're like, oh, well, now I have 500 spam emails from things I never signed up for. So that's my thoughts, is that there would be a spectrum, and I think not necessarily the case that will be that everything that is posted is there permanently, because you might just not choose to share it.
I totally agree with the statement that you said about whatever happens stays in the internet, and I also agree with what Pavel just said, at which so the existence of blockchain kind of solidified the fact that whatever happened will be recorded, and it's being recorded as the block hash instead of some random data in Google's database, right? Like a block hash is more reliable than a database piece of information. And we are also, and there's also like the idea of bandwidth, right? Like because blockchain is limited, so whatever gets recorded will be more, I guess, precious in a way. Like people don't, because you have to like spend gas in order to record your data to make a transaction on chain. So it kind of makes you to be more conscious of the trail marks that you leave on chain, and what's being left on chain are more valuable information. And in addition, with the add-ons of zk proofs, I guess like more to the fact that like the information that you leave is more valuable, but also it's proven. So I guess it will be a more solid timestamp on the activity that you make, the transaction that you make online, than like, you know, whatever you do on Facebook or Google. So I think blockchain is a good add-on the Web 2 ecosystem in that sense.
Yeah, and honestly, that kind of like brings this thought into my head. So, I was at we were talking about like how we need the bandwidth, and we like most protocols, they outsource that bandwidth to a third party, right? Whether it's like a third party server, cloud computing service, or anything like that. So, what was the question that I was asking? I felt like it was going to be a good question, but I'm kind of forgetting right now. It was just kind of more, what do you guys think in terms of like decentralization and using these cloud providing services to kind of execute these transactions? Some of these are decentralized projects, protocols, or companies. Do you think that that has any effect on our initiative for just a decentralized blockchain?
Yeah, I mean, definitely. Because right now, if you look at the PBS situation that we're having, like 80% of the blocks are being relayed by centralized flashbots relayer, right? Like where the flashbots are currently working on decentralizing that. And Taiko as a layer 2, we started off trying to like come up with a decentralized layer 2 as a premise, right? Like honestly, like even zkP isn't our priority, because like we know that there are so many projects that are out there, people that are good at doing zero knowledge proof, and what we're working on is to provide like a robust platform for people to like to improve on this technology and apply this technology in a decentralized way, right? And going back to your question, so Ethereum is definitely like halfway decentralized, I would say, because there are a lot of validators out there. However, there are some centralized component that we couldn't avoid. For example, the relayers. For example, people are staking with Lido, which also has some centralizing aspect to that, right? So I think there's always a trade-off, and the goal is always decentralization. But in our way of getting there, technology itself has a limitation, and it has like a time frame. Like we need to be patient, right? Just like how we're being patient with Web 2. Yeah, so I think there is definitely an aspect of, you know, like the trade-offs of, you know, decentralization.
I agree. There's trade-offs, and I think like the balance between decentralization is a spectrum, and the goal is that ideally you don't want there to be any single point of failure or any single entity that can just come in and take all the money, or come in and say, no, your privacy is mine, or all of this essentially to be executed in that way. I think that most systems, as you said, I guess like Ethereum partially decentralized. I think a lot of the rollups have centralized sequencers as well. Yeah, I know Metis is looking to make sequencers decentralized as well. But there's always, as you said, trade-offs to these different types of decisions. And I think that the goal of it is that we want to create systems that don't need any single entity to operate, and then those systems other people will build on top of, because they're open, permissionless, you're able to develop, deploy, and I think that those systems will last the longest if you create that open space and provide people with that opportunity. And I know that there's like some decentralized cloud providers, I think 𝘝𝘐𝘚𝘐𝘕 that are there. IPFS, I guess, has its own system of hosting. So I think like the progressive move for applications to utilize these types of decentralized services, we're seeing more and more of. It still might take a little bit of time to balance out centralization, decentralization, because we all want our NFTs to like load immediately, but you need a way to cache them. So that's the trade-offs there, but hopefully that the core systems will be there for the future to come, and for that success to take off.
Yeah, decentralization definitely does seem like achievable, but also, like you said, it's like we're doing a fine tango between decentralization and centralization, especially when it comes to like, governing entities, and we're all citizens of at least one governing entity. So it all turns into a fine little dance, But but yeah, I see that there's a lot of questions that have been flowing in. Pavel, Cecilia, would you like to? I'll read them out. Would you guys like to address these questions?
I actually don't know where to see the question.
I got you. I can read them out for you. Don't worry.
I think in the bottom right you can click the chat button.
Oh, okay.
But yeah.
Yeah. But yeah. So guys, listeners, go ahead and put your question. If you haven't asked a question, go ahead and ask. But we'll start with the first one on my screen from 𝘝𝘐𝘚𝘐𝘕. So, what use cases are you particularly excited about that your respective projects are aiming to achieve? He knows that you already touched on this, but is just asking again.
Okay. So for Taiko, I think like me personally, I am the most exciting about the multi-proof paradigm that we're going to have and contestable rollup protocols that we are going to deploy when we're on mainnet. So yeah, so like I said, there are a lot of good zkVMs out there and zkEVM solution, and we're definitely aiming for something zk, right? We're definitely going to prove what we execute, what our decentralized propose are honest. Like we're definitely aiming for some proofs, but whether that happens in zkEVM or zkVMs are up to the latest state of the industrial development, right? Like with that paradigm, we'll be able to like deploy with like the latest technology immediately if we can truly have like a backward compatible generalizable rolled out paradigms. Yeah, so that's the one thing that I'm most exciting about. And maybe we can collaborate with zkM as well if we can compile like an executional client into MISP instruction set, and if zkM can like prove our protocol timely, then zkM can be one of our go-to solution for zero knowledge proofs. So I think like that in that aspect, like the generalization aspects of Taiko is very, very exciting to me.
I'm glad you mentioned the ability for zkM to prove the Taiko transactions and ensure finality. We're actually working on a solution called a hybrid rollup, and essentially it's taking what's called optimistic rollups or OP-based rollups, and then ensuring that the withdrawal time is I know it's 7 days right now, but with this introduction with zkM and specifically that hybrid rollup module, we want to eliminate that withdrawal period, essentially with the finality guarantees by the zkVM that we've created. So definitely open to more of a discussion on how we can attain that with Taiko as well, and then that I think that we can definitely work together in that space. Yeah, but that might be a different call. But yeah.
Yeah, I'm a different call. We might have to do a little bit more internal conversation, but that's super exciting. And yeah, I have to say the use cases for zkEVM are quite extensive and can definitely help out with Taiko in this multi-proof paradigm for sure.
Yeah, thank you guys. Thanks for the support.
Yeah, that's super exciting, guys. Welcome. You guys are hearing our usual like meeting talks on Twitter Spaces. How exciting! Okay, and then so we're just gonna go through the questions from 𝘝𝘗𝘁𝘶𝘚. Can zkEVM be utilized by traditional banking, say by data analysts when building Intr to detect fraud?
Yeah, in terms of traditional banking and fraud, there is a multi-layered process for traditional banks. I don't know if anyone here has sent a bank transfer or anything, for example, like internationally or whatnot. There is a very significant waiting period, and then there's different types of processes put in place, specifically like AML, so anti-money laundering, and that fraud detection. So can zkEVM be used to potentially detect the fraudulent transactions? There is ways that we can componentize different systems, maybe make zk proofs for specific aspects. Fraudulent transactions, there's a number of different say sources for fraudulent transactions, like someone stole my credit card and started making payments. In that case, those are still legitimate transactions. It's just done in a fraudulent manner. But in the way that I want to ensure that the transaction did succeed, that I did receive the money, that I did, for example, execute this transaction, I did do this thing. Here's my proof. In terms of those types of systems, yes, we can. And I think that there's definitely ways that we can integrate zkEVM into or zkMIPS technology into various different types of traditional components. But there might need to be a little bit more thought on how to do it in the proper way. But yeah. So a short answer, maybe.
Yeah, it's really hard to say. And Cecilia, I'm pretty sure, like, correct me if I'm wrong, but I believe zero knowledge proofs have already been used kind of in the financial industry, and this has already been addressed by zkEVMs, right?
Financial industry. Well, I'm not sure how does the adoption comes to like the TradFi landscape, but yeah. Can you rephrase your question? What do you mean by like zkEVM specifically applied to the financial industry?
Well, just more of like, so, and Pavel, feel more than free to correct me if I'm wrong, because we've had conversations about this before, but like kind of like what we see in the blockchain space with optimistic rollups. I know that Taiko is not an optimistic rollup, but like they kind of have a similar scheme to how like traditional banking is already done, in terms of like saying, hey, yes, I sent this money over and it's going to be pending, but it's kind of like this is true until proven false, right?
Yes.
And then the zkEVM is just a tool that takes that, settles, uses a zk proof to submit that proof and verify that it is correct, right?
Yes. So that again, that comes back to the security assumption that we have, and how much do we want from like the trade-off between speed and finality and security, right? If we can tolerate the fact that like my transaction is pending, well, it's been submitted on chain. If optimistically, I can assume that someone had carried out that transaction, some executional client had executed that for me, and it's honest. Now I have more money than before, right? So that's optimistic rollup. But in zk rollup, we have a more strict assumption, kind of assuming like a malicious party scenario where your executional clients could not be honest, so that I demand a proof for me to trust the fact that okay, you guys actually transfer my money. So that's the idea.
Yeah. So like basically, like what I was trying to get at was just like we're kind of already seeing us kind of inch our way that way, but we're still blockchain space, we're still growing, still in infancy. So like we're getting there, but like we can already start to kind of like see these little steps towards the full adoption of crypto, and then using zk to like fully secure, you know, your transactions and whatever kind of transaction it might be, whether it's information, like execution or anything like that, right?
Yeah, yes. So if we relax the type of computation that we tolerate on, we can totally roll up like like a non-EVM type of computation. For example, like any general purpose programs that are being carried out by zkVMs, whether that's in MISP or WASM or RISC-V use instruction set, anything, as long as you can prove it and provide like a state transition status that people can witness, right? As long as that's the premise, we'll be able to roll up anything on chain. Yeah, so in that case, then we can literally scale Ethereum in like the computational aspects.
Awesome. And this is just kind of a question for me, and then I'll get back to everyone else's questions. But as far as reduced instruction sets, does Taiko's zkEVM utilize just like one specific one, or are you guys able to kind of like translate through different instruction sets?
Good question. So currently, we're actually working on. So we are collaborating with RISC-0. There is a version of our prover that is being run on RISC-0's Bonsai, but we haven't announced that as our one of our multi-proof paradigms. It probably will be by the time we launch mainnet, but that depends on whether RISC-0 open source their ZKPs. And we're also working on an Oracle prover that is run on SGX, right? Because although like SGX is not ZK, but it's some security guarantee of the computational integrity. In addition to the zkEVM that we've been developing with PSE. So these are the current existing solutions that we have, but we're definitely looking forward to collaborate with more zkVM providers. For example, zkEMs and zkWASM. So anything, as long as a Go client like Geth or Reth or a Rust client of Ethereum can be compiled into like some target instruction set. And as long as it's performant, we'll be able to deploy that.
Perfect. Yes, because like coming down all the way down to the base level, being able to be kind of fluid with the type of circuit communications you can use is, I think, very important. Excuse me, one moment. Still coughing. But okay, so next question. How do sorry guys. How do zkEVMs and zkVM technologies address scalability, privacy, and exciting use cases in Web3 platforms? We kind of touched on this, but let's go ahead and just quickly touch on it again.
Sure. I can answer first. In terms of zkVM, we're tackling that privacy and scalability using the MIPS instruction set, and again, that's general purpose computation. So you can run any form of computation with the MIPS architecture, and essentially be able to prove that computation and prove also without actually revealing the information about that computation. You just know that the result was performed and that the computation was done. So in this way, it can be done through multiple, I would say, results can come from that. The privacy and security, and let's say if you're creating like a game, the simplest way is the game. Maybe it's like a little bit inefficient, but if you're creating a game that's fully decentralized, you don't want anyone to know where you are positionally, then in that way you can mask your location from anyone, only to prove that you're actually there, but you're essentially hidden. So that can be generalized into different examples. That might have been a little bit of a bad example, but it can be, whether it be for your health records, it can be for essentially any type of personal information. It can be any type of like, hey, did you do this work? Can you prove to me that you did this? Or prove to me that this computation executed successfully and that you've actually done the work. It can be used in various different applications. And so I think that just utilizing that verified computation as well as privacy, we can think of essentially limitless use cases, especially when thinking of essentially smaller machines that are like for example, Pis, Raspberry Pis, Arduinos. So you have like the smaller like machines that are basically everywhere, and then you can essentially offload computation to the network of these types of nodes, and then have them process different types of work. So you can essentially extend computation even further, expand that and scale that in those ways. So hopefully that answers that question.
Yeah, for sure. And like, I mean, it's just kind of crazy because when you think about it, no matter what, whenever you're sending, it could be a text message, a photo even, or just any kind of information that has to be sent from one place to another contains the metadata. And through that metadata, like I remember even back when I was in high, if you sent me a message on Facebook, I could simply just go into my terminal and look up what IP address you were sending that from. Like I could know your location, essentially. So kind of like bringing that privacy forward is just one use case from like zero knowledge proofs and this technology being incorporated in the base. But yeah, there's thousands of use cases that could come from this, which is super exciting. And then next question: what are the key challenges what key challenges do you see in the broader adoption of zkEVMs and zkVMs, and how do you envision these technologies evolving to address these challenges in the coming years?
Okay, I can go first. So I still think that like the problem is adoption, right? Like all of the rosy picture that we painted sound very good, but still, people are actually, the projects that I've know of are actually still struggling about finding a use case. For example, if you guys have heard of zkML, like eZKL, the zkML, ZK machine learning program branches out from the PSE. So like they actually created like a pretty robust proving system based on Halo 2, and they create also like a Python front end binding. I personally used it. I kind of contributed in their code base for a bit. Is a very good project. However, they're still struggling to look for people who use it. Like we always talk about, it would be cool if we can serve the data to train or serve the data to inference, privatizing it. And the technology is actually out there. However, no one uses it. Or what is the actual, you still need to incentivize people to make them aware of the fact that my data is actually, something that is very valuable, and I can utilize blockchain technology. So like all these UX aren't ready yet. So the on-ramp experience is still very bad. And for people who uses the blockchain, like what's the motivation of me go onto the on-chain to train some data of like something related to myself? Like I still think that it's a continuous process, is a UX experience with integrity, right? Like it's not just we paint a rosy picture and then we say that this could happen, it would be cool, and it would just happen. I don't think it goes that way. Yeah, so that's my take.
Yeah, I like that you're saying that the rosy glasses of the experience of like, oh yes, future, but it's the hard part is that you need easy systems to onboard. You need good user experience. You need a good support. So there's a lot of infrastructure that needs to happen before I would say a lot of solutions take hold. But I do think that the systems are there, technology is there. We just need to essentially build systems that are friendly for people, and not just research groups. And I think that having this type of strong developer community, as well as just people that are interested into this technology, I think that's a good start. But I think definitely more applications, more use cases, more and then just simpler systems for onboarding. That would be essential to have adoption of even the most revolutionary technology. So I'll leave it at that.
Yeah, absolutely. And before we go on to the next question, I just wanted to also add, like, not only do we need everything that Paul just mentioned for adoption, but also need to kind of change, like what Cecilia was saying. It's kind of mind-boggling that we have to convince or change our psychology in believing that our data is more valuable than what it has been said to be, because like your data is what runs kind of the entire world. That's how everyone kind of picks up the demographics, where they should market, where they should, like, you know, open up a even. It's outside of blockchain as well, but we kind of have to like change the overall psychology of the entire industry or the previous industry into like understanding that everyone's data is valuable, and you know, you should own your own data versus just giving it away every time that you step on a web page and press accept all for the cash, you know, pop-up that you get on every website that you go on to. But yeah, and then next question. These are kind of similar questions, and we already addressed them. Savior J and Jakarta, you're asking if there are any challenges and limitations of the zkEVMs and zero-knowledge proofs in Web3. We already touched on that one, but if you guys want to go a little bit further with it, just DM us and we'll answer those directly to you. And then, so the other question, how does zkEVM, zkVM's technology contribute to the scalability and privacy of Web3 platforms? We also addressed that one, but Sir Pat, go ahead if you want more information. And then we already touched on being crypto.eth is asking what challenges are you facing to build and adopt zkEVMs in Web3, and how are we going to solve it? Pavel, Cecilia?
Sorry, can you repeat the question?
Yeah. Sorry, I was kind of reading. What are the challenges you guys are facing to build and adopt zkEVMs in Web3, and how are you guys solving?
Yeah, sure. So yeah, let's continuing what we just left off in the discussion that we just had. Right, I was kind of inspired because you know, when years ago we were talking about like smooth Web3 on ramp, right? And now that we kind of have that, because PayPal just opened up a portal for general public to just, you know, spend their crypto. So it's an easy way for people to, like, you know, spend their USD to like on ramp their USD onto blockchain. And people can also buy like ETFs, right? Like the money flows now these days. But in terms of ZK, do we have that on ramp for ZK? I think that connects to, you know, when we were saying like we're trying to convince people that your data is actually available. And honestly, if you have an easy UX for user to be like privatize your data by one, I guess most people will click that button, right? But we don't have that. I think that's something that we need to work on for as in ZK industry in Web3, or not in Web3, you know, like ZK in general. Yeah, so I think that's, you know, one thing that we as an industry to work on to like not only incentivize user to privatize their data, and also like, you know, make it easy for them to privatize their data.
And to add on to that point of privatizing data, I think there also needs to be a financial incentive to do so. That when you have data privacy, then you're like, okay, now I get to control what data that I can sell. And just like how I guess Google surveys are doing something like that. But again, it's all Google associated with you. So in this way, I think the rights and the data going back to the people, and then them having that financial incentive, I think is key for for that type of growth and adoption. And then I think I mentioned like just previous points on just growth and adoption, like UX and various different types of just we need to create systems that benefit more so the general user rather than the researcher. But still, we still need a research-focused mindset on how do we benefit the end user. But I guess you need you have the chicken and the egg. You're like you need one to have the other, and yeah, essentially it's a straightforward path, but still takes some incentivization to get there.
Yeah, for sure, absolutely. Especially like we're trying to grow this out organically, but you know, there needs to be some reason for people to like move from the comfort of Web 2 and push themselves into that like catapult into Web 3. So incentivization
NFTs.
Yeah, NFTs and one airdrop, you know. But awesome. And then I'm gonna go ahead and pick the last questions by Prince. It's why just zkVM as its own operating system instead of zkEVM when it's going to still be a stack for layer 2s and Ethereum the main settlement layer anyways.
Oh, I think that might be.
I think that's more towards you, Pavel.
Yeah. In this case, so just to rephrase the question, why call it KVM if we're still publishing the proofs on Ethereum, essentially? Like, why isn't it zkEVM? Is that the question, or is that my is my interpretation?
Essentially, yeah. Like, why are we using a zkVM as an operating system when like zkEVM is already a combat, you know?
Mm-hmm. Mm-hmm. So in our case, it would be more for general computation. So zkEVM has tool sets specific to the EVM. So they have the opcodes, and it's specifically tailored Ethereum's execution. And so they built their instruction set in that way. We are focusing more on how do we integrate more real world applications and prove and verify the execution has happened using devices that are not part of the EVM. So just think of just the IoT devices. Think of a server. Think of anything, any system running that utilizes like the MIPS architecture. We can utilize as a part of this to generate proofs off of. We do that all on Ethereum, so that is still a part of it. We still use the EVM, or we still use the Ethereum as the settlement. But in this way, we do computation as a generalizable. We generalize computation. So hopefully that answers the question. And then if there's, I guess I'm trying to find out like the analogy for this, but I guess the best way is like we just do general computation versus zkEVM does computation specific to the EVM. Hopefully that answers that.
Yeah, just to kind of like add a little bit on there and kind of, you know, showcasing our roadmap for the audience and for you, Prince, since you asked this question, is like right now zkVM is working on its virtual machine to address first optimistic rollups, then alternative layer 1s, and then move on to IoT devices later on. So like once we, you know, done in step by step. But the reason why we're using a purpose zero knowledge virtual machine is because then we can connect, you know, alternative layer 1 and settle those proofs on the Ethereum blockchain, so that makes Ethereum the true main settlement layer, you know, rather than just having on their own siloed alternative layer 1. Okay, great. And that is, I believe I got almost all, questions. Just to the audience out there, before we close the show and tell you what to look forward to from each protocol, so stay on for just a moment. go ahead and take a screenshot. We're giving away a Nouveau badge like we do for every MetiSpaces show. So take a screenshot of this Twitter space and DM it to the MetiScal Foundation Twitter, and we will send you your Nouveau badge so that you can add on to your soulbound reputation. But all right, so go ahead and take that screenshot, send it over. Irina and I will be in contact with you. And then one of the last questions was token or no token, McRaleigh. You'll have to find out. That goes into our announcements. We at zkEVM, they have the early contributor program that rolled out last Wednesday. Probably give us a little bit of an update, or just let us know what the ECP is.
Yeah, of course. And I guess to emphasize token no token, it's the ECP is focused primarily on developers looking to run their first proof using zkMIPS. And what we're doing is anyone who participates gets points, as well as the first 100 people that submit a proof and verify that they have submitted it will get a .zkM domain, or the .zkM domain, which I guess that's the incentives there. So yeah, we've launched this very recently. We have, I think, over 11 people that have submitted. But so there's still time to be one of those people. It's available on zkm.io/ECP or just zkm.io, and you should see like a big thing that says "push me" for the ECP. And yeah, essentially just if you can go through the whole tutorial, and I applaud you, because then you need to install like a lot of packages and all that. So yeah, and of course join the Discord. There's definitely, like, I would say a lot of it is in progress. So obviously we want to create the best possible experience for anybody new joining. We want to enhance that user experience. So any feedback, any questions, any problems, or if you just want to yell at me, then then yeah, feel free to do that in the Discord. And that's yeah, I think that's all my updates
for sure.
for ECP.
Awesome. And you guys are looking for the Discord, go to zkm.io. We got all the links in there. With the early contributor program, we're rolling out in 2 phases. So first is Community Edition running the demo, and then second phase, you'll claim your domain and you'll be able to kind of cement your contributions on the blockchain and receive incentives for that. But as far as a token for zkEVM, we have absolutely no comment now. And then Cecilia, tell me what's going on with Taiko. What can we look forward to that coming up?
In terms of airdrops and token, I don't know, because I'm just like a pure dev, right? I'm not a DevRel. But our testnet A5 is currently live right now, and we're testing out a decentralized proposer and prover protocol. So if you guys are into MEV, are into like block proposing and all that hacky stuff, you can totally come to our protocol and propose some blocks and get some test token. And I don't know what will happen to those tokens. Maybe like we'll have airdrops later on, but I don't know. And we might have another testnet before Istanbul, the DevConnect that will happen in November. Maybe we'll have like a testnet A6 that we further test out, contestable rolled up. So that will be a lot of fun as well. So yeah, I just encourage all of the Node Runner developer to just try everything wild on Taiko. Yeah.
Awesome. And then can you let us know where we can all go to get involved? Is it just taiko.xyz?
Yeah, just go to taiko.xyz and check out the documents, because that's
Okay.
where I go, right?
Yeah, absolutely. And guys, if you guys are developers out there, come on and come in with us and build with us. We need your contributions, your feedback, and just overall, we just need you in order to build a better product and kind of push this adoption towards blockchain forward. So go ahead, join go on taiko.xyz or zkm.io, get in our chats, and we'll all be here and happy to talk to you guys. But awesome. Cool. And that'll wrap up of our show. Pavel 𝘝𝘐𝘐, he is DevRel lead at zkM. Cecilia is the ZK engineer at taiko.xyz. And I'm Kat. I do the events at MetiSpaces Foundation, and I'm a coordinator for zkM as well. So thank you guys for joining us. Keep on chatting us, asking us questions in Twitter or in Discord, Telegram, wherever you are. And thanks for joining us today. Thanks, Pavel. Thanks, Cecilia.
Thank you, Kat.
Awesome. Thanks, Kat.
All right. Have a great one, guys.
Have a good night.